Hello and welcome back to Building Microservices with Go. And with me, Nick Jackson, and it's been a little while. Can I kind of apologize? I've just been kind of feeling a little busy, as everybody has at the moment, but I really do hope you're all keeping safe. So what I want to do in this episode is I want to take a look at refactoring. And specifically, I want to kind of refactor some of the code that we've written so far to get it ready for the next level. And the next level is I want to start looking at gRPC streaming. So let's begin. Some of the things that I want to look at when I'm doing the refactoring is kind of give you some hopefully some insight into what I'm thinking. I think the key thing to remember is that nobody writes perfect code first time. Rarely. I mean, I think quite often you find that you think you've maybe written some good code, but more often than not, you end up changing things. And I think the key thing about writing code as well is you develop what you need for when you need it, rather than trying to, overly thinking everything. So what we're going to do is we're going to go through some of these services. We're going to pick up where we left off when we were partway through looking at gRPC, and we're going to get ourselves ready for implementing the next big section of gRPC, which is bidirectional streaming. So let's begin. So the first thing that I want to look at is our currency server. So when we originally implemented this currency server, this basic gRPC server, we were just wanted to get something working. Just wanted to kind of test something just to kind of prove the concept. But I think it's time to kind of start putting a bit more logic into here. So what we're going to do is we're going to implement a new data service, and what the data service is going to do is actually going to retrieve us exchange rates from the European Central Bank. So let's have a look at this. So what I want to do is I want to add a new package, and I'm going to call my package data. So I like to take this approach when I'm building my services. I like to do things like putting handlers or gRPC endpoints into things like server. I like to keep things for my protobufs in, protos, and like data objects, databases. It feels good for me to put things into packages like data. When we start to look at things like testing, which we're coming up to very, very shortly, you'll understand, I think, why it's good to have a nice clean separation between the different layers of your application. It enables a very sort of efficient testing approach. But for now, we're just going to implement that rates service. So I'm going to call it rates, rates.go. And my package, is data. So what I need to do is I need to create a structure. And the structure is going to be an exchange rates strut. So I'm going to define, again, type. I'm calling it exchange rates. It's a strut, and it's going to have a couple of properties. So one of the properties that it's going to have is a logger. Really, really important to be able to find out what's going on, have that sort of passive debugging with log files and things. So I am using hclog, and hclog is a package. There are a number of different loggers available. It doesn't really matter as long as you kind of choose something and keep running with it. So this exchange rate, what it's going to do is it's going to hold a map of exchange rates. And the rates are just going to be marked by a currency code. And we're going to define just a float for the value for those. So following those kind of good Go idiomatic practices, what we want to do is we're going to create a new function. So func, new rates, and this is going to just take a single thing and it's going to have a logger. So it's going to pass in an instance of hclog.logger. It's going to return an exchange rates reference and an error if it can't create something. So there we go. We've got the kind of basics laid down there. So now what do we want to do? Well, we want to be able to get the exchange rates from the European Central Bank. So first, let's just define our collection of exchange rates that we're gonna kind of get. So let's create our exchange rate object. We're just gonna call it ER, and it's gonna be exchange rates, and it's just gonna have log in there. And then what we're going to do is we're going to instantiate the rates collection, have map, string, and float 64. Well, way too many float 64s there. Maybe floats of maps and maps of floats. Float 64. Wow. Sometimes you can't get IntelliSense to work. Sometimes it just works too hard for you. Just do as you're told there, you little thing. All right. So we've got that running. So we need to be able to populate those exchange rates and get those from the European Central Bank. So what I'm going to do is I'm going to define a function called getRates, and that's going to make a call, which is, it's not a RESTful API, it's an XML based API, but it's going to make a call to that, and we're going to be able to retrieve the data from there. So first things first, let me just clean this up so that it's going to pass, just to kind of get rid of any error messages. So the URI that we're going to hit is this one here. Let me just quickly bring this up in my browser, and I will show you that. And I'm going to zoom that up. So this is on the European Central Bank. And what this is an API which returns the daily exchange rates for the main European currencies and global currencies such as the US dollar, etc., etc. So we can see that it's coming back. And this is the structure that it's returning for us. It's not JSON, it's returning us a Java, gosh, I'll be in trouble. Always associating Java and XML, but it's returning us an XML data structure. This is fine. We can actually parse this with Go. Let's look at it. So what we want to do is define ourselves a getRates function. So I'm going to do func, and I'm going to add a method onto my exchange rates object. So e exchange rates, calling it getRates, and it's going to return an error, because if it's successful, it's going to set a value on itself. So let's see how that is going to work. We're going to get that data. So how are we going to get the data? We're going to use the standard Go API. So we're going to do response, error, standard approach, http dot, default client, and we can just make a simple GET request. We don't need to pass an API key or anything like that. So we can just use the kind of the bog standard request. And we're going to use that XML-based URI that we had from before. Idiomatic Go, if error, return nil. Okay. And now we can start to handle the request. So the first thing that we want to do is we want to check whether the response, well, has it been successful? Have we got a 200 code? Because if we haven't, there's absolutely no point in even processing anything further. So let's do that. So we're going to say if response dot status code is not equal to http dot status OK, then again, we're going to return an error message. And we're not going to return, we have to create the error ourselves. So it's going to be return format dot error f, and we're going to say that we expected error code 200. It's not really an error code if it's a 200, it's a success code, right? Anyway, we expected a 200. What we got was, well, what did we get? Whatever came out there, response dot status code. So that's going to be set up like that. And then we obviously always want to close that response body, just kind of get rid of that, clean everything up. So we're going to put that in a defer statement. So now we can start processing our data. So we're dealing with XML. Now with Go, the nice thing about Go is that we can use the package XML. Well, encoding XML. Let's take a quick look at that. So we have an API here, which is very, very similar to what you're going to find with the JSON encoder. We've got things like an encoder that we can create. Same way, there's a couple of extra elements, but for predominantly, you know, you could see yourself just using new encoder.encode. Like the way that we build up our JSON encoding, we can also use tags and things. It works ever so slightly differently because XML's kind of structure, but it's easy enough. I genuinely hope you never have to deal with XML. It was a wonderful, wonderful thing at one point in time, but yeah, not anymore. I think it's had its day. But anyway, let's look at what those structures are going to be like. So what we have is this structure here in our data. We have this cube, which is quite a top level, but it's the top level after the XML envelope there, SOAP envelope. And then cube has a cube in it, which has a cube in it. Because I mean, why wouldn't you? But that's exactly what I would do if I was creating XML. I would have 3 layers all with the same object and slightly different parameters. Right. So we're going to moving on, and we're going to look at those objects. How are we going to create them? So what we're going to do is we're just going to use structs. So we can do type cubes strut, and we are, well, what we're going to call this. I don't know if it particularly matters, but I'm going to call it cube data. And it is going to be a slice of cube, which I'll define in just a moment. So we can use these XML strut tags. So I'm going to add XML. I am going to specify that I want to extract the cube from the cube from cube. Well, you're actually going to read it backwards. But we're going to get all of the cubes into this slice from the cube in the cube. Okay, is that all these cubes from this cube in this cube? Clear as mud, absolutely. Right. Once defined, always forgotten. We don't need to worry about this anymore. Let us define our cube to put our cubes in. And what is cube going to have on it? Well, let's again look back at this thing. So we have currency and we've got rate. So we need to add 2 types. And we can define these as strings because they are pretty much just strings. It doesn't really matter. Let's just do it easily. We can convert it later. So then we're going to do currency. And it's going to be a string. And again, let's use those strut tags. This time we're going to say XML currency, currency, and atta. Right. What is going on here? So what I'm doing is I'm using a strut tag, and I'm defining that I want to extract the currency attribute from that bottom level cube. And we're denoting that we want the attribute by using the strut tag here, attra, for the XML encoding. So I'm going to do rate, and I'm going to do string, and again, XML rate, attra, atta. And that's all we kind of need to define our data objects. So now what we can do is we can go and we can fetch that information. So when we want to fetch the information, what we can do is very simply we can use a decoder. So let's first create our collection that we're going to put data into. So we want to create our containing structure, which is just cubes. So MD, and I'm going to call it MD cubes. And then to get data into there, exactly the same as if you were using the JSON decoder. So XML is one of the lovely things about Go. A lot of the standard libraries, a lot of care and attention has become put into these things to kind of make it feel very, very familiar. If you've used one type, a lot of the others are very, very familiar. It's a nice thing. So new coder, that takes an IO reader. We can get that from the response body. And then what we're going to do is we're going to call that decode method. And we are going to pass in the reference MD. Okay. So now we've got our code there. And they're going to be stored in there, but it is a string at the moment. So what we need to do is we just need to loop over this collection, convert them into floats, and put them into our array up here, which will be quite easy. So let's take a look. We are literally just going to loop over it, loop over the collection. If I can type, which I can't, always the keyboard, correct, Ivan. And md dot cube data. Oh, I can't spell range. md dot cube data, like so. What should I call that? C. Okay. So then I can just convert that. So I'm going to call my rate. I need to get an error. And then I'm going to do string conv. And I can do parse float. I can get my rate from there. And what is the sort of the size that I want to put it into, the bit size? Well, I want to create a 64-bit. Whoops. Wow. There we go. Not 65. You don't want a 65-bit. You want a 64-bit. Now, let's tidy up this. What is it? This thing complaining about? It hasn't auto-formatted, which means there's something gone awry. Well, we'll take a look at that in just a moment. So first things first. So if error is obviously not equal to nil, then I'm going to return the error, because I should be able to parse every single one of those. And if I can't, I want to throw an error out of that. But once it's done, what I can do is I can set my collection here. So I can set e.rate. It's not correct as it should be. It should be rates. Let's correct that before my OCD gets in the way. All right. So we want to set e.rate, which is a map, takes a string. So we can use the cube data that we're getting, and we can use, what did we call it? Currency, which is our currency code. Currency. And then we can just set the value there, which is going to be our rate. And that is pretty much all we need to do there. We can do return nil because we're not returning an error, but we're pretty good there. So we've got that code. That's all good. So let's test this now. It's kind of a bit of a catch-22 for me, because I wanted to introduce all of these concepts in a kind of a very straightforward and, well, like a very structured way. I had this kind of grand design that I was going to talk about gRPC and RESTful before I talked about things like testing. And I kind of still maintain that, because I don't want to overload people before get to kind of a really, what I think is a little bit of a complex topic. But at the same time, tests are incredibly useful for just checking your code as you go along. It saves you a lot of time of having to spin up the application, and kind of keep things running. So what we'll do is we're going to do a little bit of a little teaser of what's to come around testing. And I'm going to show you how to write a very simple test in Go, which is going to allow us to kind of test out our new rate service. So I'm going to add a new file. I'm going to follow a convention. So test files in Go follow a convention. Rates test.go. It doesn't matter what I put before underscore test, but underscore test signifies that this is a test file, and therefore it'll be ignored from most of the compilation. I have to put it in the same package. So package data, and then I can define my test. So a test, func, test. Now, every test that you create in Go must start be a function. It must start with the word test. So I'm going to do test new rates, and it must have the sort of function signature t dot testing. Doesn't return anything, and it's refusing to import, but we'll get it to import there. So import. There we go. Oh my word. Sorry. Testing dot t. It's a little bit late. Everything in my brain is backwards today. So this is what a very, very simple test function works. Now we've got there's a little comment there from Edwin about table testing. I'm not the biggest fan of table testing, and I'd have my reasons for that. My predominant reason around why I'm not a huge fan of table testing, and I prefer a more sort of a verbose approach to testing, is readability. And this is very much a personal thing, and I'm not advocating that everybody follows the same thing. But for me, I find I can't decipher in my brain what's going on in a table test. And I can when I have a very sort of verbose approach. So I tend to have function names for my tests, like test new rates does something and returns something else. Because when I look at that, I can decipher what's going on there. With a table test, I find it quite difficult. But we'll take a look at both of those options, because as I said, everybody's got to find the best approach for themselves. But test new rates anyway. We just want to create a test on this. So we're going to create our new rates. I'm going to put a logger in there. So let me just do hc log dot default. And then I can call the get rates on there. New rates returns me an error, doesn't it? Yes. Okay. And then what we're going to do is we're just going to do something very, very simple right here. And we're just going to say if error is not equal to nil, then what we're going to do is we are just going to do t dot fatal error. So I want to fail the test immediately, and I want to pass this error. We'll kind of, I'm pretty certain, see how that works in a moment. Then around tr, well, I mean, just for now, let's just print that out. So format dot sprintf, and I'm going to do if I can find on my keyboard percentage hash v, going to do tr dot rates. So let's just get rid of those rates, right? So if you're using Goland, or if you're using Visual Studio, or if you're using Vim, or anything really, there's a number of different ways you can run tests in Go. You can use the command line. So I can use go test. We're going to look at all that. I just kind of want to show you something quick here, but I kind of like running this. I think this is a really useful thing to do. So there's that error as expected. So it's kind of we've got a syntax error. We must be missing a brace somewhere. Let's have a look. Line 53. And we have, no, we're not missing a brace. We are missing a speech mark there. And let's see, what else have we got? And we've also spelled struct wrong. Well, all the things. But it's formatted there, so I think we're back. Run test. Okay, cool. So that test there passed, which is a good thing. Now, I want to kind of have a look at those rates, and if I run like go test in here in Visual Studio Code and it's passing test, it's going to kind of hide all of this stuff because it's just burying it for me. So I'll quickly show you how we can do that from the command line as well. So I'm just going to go to currency. I'm in this folder here, so I can do go test -v for verbose mode data / rates test. Let's just run this. Sorry. Let's just test the package. So we can see everything is all good there. Let's see if we can get this. Why is it not? Oh, wow. Look at that. Wow, wow, wow. sprintf. We don't want to be sprintfing. It's very late. There we go. So we can see we're getting that map there, and we could just loop over this and just kind of play around. But one of the things I think is really useful here is this debug button. And again, I'm just going to give you a quick teaser into what's coming and some of the things I want to show you. But with a debug test, what I can actually do is debug my code. So I can go down here and I can set a breakpoint. This is using the delve tool. And again, I don't want to go too much into this, but there are some nice tools with Go. I hit my debug test button, and that's going to execute my code, but I'm going to stop at my debug. Well, it doesn't be getting any data back. So this is interesting. I can actually debug this. Let's just set another. Oh, well. Come on, chat. You didn't even notice that we weren't actually even calling the rates service. Let's do that. So we're going to do get rates. We'll seed it. And that will kind of set that up. It'll populate everything. And of course, get rates, well, we can just return the error from that. And then if that's null, it'll be fine. So now let's go back over to our test. Let's do it in the terminal. Running our test, and you can see there now we've got all of this data coming back. So this is what we expected. Again, let's just hit that debug test button, and I'll show you this. This is a really wonderful tool. So I can step through this, and I can kind of see all of the values. You can see them there on the left-hand side as I kind of step through. So it's a really powerful tool, and we will look at this and a lot of other tools as this kind of course progresses, because we do have there's a lot of complexity when it comes to microservices, but we'll kind of get there. But I think for now that's a little bit of a starter. I'm going to do more of these debugging videos and more of these refactoring videos to kind of just go through, and I'll do those over the next sort of couple of days. I hope you find it interesting. I'm kind of hoping that this sort of stuff and having these insights into maybe some of the ways that I think is useful. If you, I'll be honest with you, if you speak with my wife, an insight into the way I think is probably not what she would see as valuable, but you never know. Some people may do. And until next time, I want to thank you again, as always, for watching. I want to encourage you to always hit that like and that subscribe button. And if you don't like, hit the don't like button and tell me why you don't like. I will make sure I do my best to fix things. But thank you so much.